Okay, we have we gone through the topic that previously which we discussed.
All not a little bit I have gone, sir.
You have gone through, and what about others? Who are all there? Aisha is there.
Yes, sir.
Okay, so we start because we time will be 40 minutes only. So we go through the topics straight away, and next we till now the interpretation part of the things we have discussed. That is alkanes. How you interpret the mass spectrum of alkanes, what are the prominent or significant fragment ions, how you can identify them. Then alkenes, and the alkanes also straight chain, branched chain we have discussed. Then cycloalkanes also we have discussed. In case of alkenes, straight chain alkenes or branched one or cycloalkenes, that also we have discussed. Alkynes also we have discussed, and later part then we have discussed aromatic compounds. Okay, what are the prominent topics for aromatic compounds, and then determination of their prominent peaks, and we have discussed. Okay. So next, coming to the halogenated compounds. Okay, so the halogenated compounds, like you have Rx. So the prominent peaks, the characteristics of mass spectrum of aromatic compounds that we are going to see today. So first thing is that here halogenated compounds, you have the M plus peak, that is molecular N peak is you can now find, and then here M plus 1 peaks are N plus 2 peaks. Okay, so will not be seen much with the fluoro and iodo compounds. Okay, M plus 1 peak and M plus 2 peaks or anything. Isotopic peaks will not be observed okay, in fluoro or iodo compounds, and but you can find the M plus 2 peaks okay, here with the fluoro or bromo compounds, that is M plus peaks and M plus 2 peaks. And for chlorinated compounds, so the ratio of M plus peak and M plus 2 peaks will be of 3:1 ratio. 3:1 ratio. And for brominated compounds, the M plus peak and M plus 2 peak is 1:1 ratio. Okay. This is the ratios you will observe, and the M plus 2 peaks, these are the characteristics of okay, M plus 2 peaks, characteristics of this halogenated compound, but M plus 2 peaks are isotopic peaks. I mean, you will not find in the fluoro or iodo compounds, whereas with chloro and bromo compounds, you can find this M plus 2 peaks. So, and for chlorinated compound, the M plus 2 peaks will be of, because for chlorine, the isotopes will be chlorine 35 and chlorine 37. And for bromine, the isotopes will be bromine 79 and bromine 81. So here you can find out the difference between the difference two mass units. So, and if you have a compound with the bromine 79, and if you have a compound with bromine 81, and the difference will be between these two will be 2 mass units, and you will may have the one peak at 79, another peak is at 81. So the peak is at 81, we call it as a M plus 2 peak, and the peak at 79 we call it as a M plus 1 peak. In the same way, chlorine also will have chlorine 35 and its isotope chlorine 37, and the difference between chlorine 35 and 37 compound 2 mass units, and the peak which appears at M plus 35 is called as a M plus peak, and the peak appears at M 37 we call it as M plus 2 peaks, and the ratio of this M plus and M plus 2 peak is 3:1 ratio, and that is because of the natural abundance of the isotopes. So here if you see that the M plus that is isotopic abundance of chlorine 35 and 37 is 3:1 ratio. And whereas bromine, if you see, that is 79 and 81 isotopic abundance, it is 50-50 ratio they are available. That's why the ratio of isotopic peaks appearance will be 1:1. And sometimes you can find out M+4 peak also, okay, and M+6 peak also. This is because of the combination of this. If you have a combination of this in the molecule, so if you have a combination of these two, okay, 39 35 and 37 both are there, then you have the combination of that. So you will have that M+4 peak and M+6, M+6 peaks you will have. So that is about the halogenated compounds. Then the fragmentation, how it happens. Okay. The fragmentation here, if you see that, generally this is the one of the fragmentation mode. You halogen compound here X we are representing, that is for halogen, and this is the molecular ion. And then molecular ion, it undergoes the fragmentation, and where you will have the loss of, one is loss of halogen atom as radical. So and this is one mode of fragmentation. And the second mode of fragmentation, the other one is that you will have the loss of hydrogen halide, okay, as neutral molecule, and you will have the fragment ion, okay, molecular ion. So from the molecular ion, loss of hydrogen halide will be there, a neutral molecule. This is one mode of fragmentation. So the first mode of fragmentation here, it is that loss of halide as a radical, and other one is loss of hydrogen halide as neutral molecule. These are the two modes of fragmentation, and their ability depends upon the loss. Okay, which one that is living group ability it is. So here we have the order. Okay, living group ability: iodide, bromide, and chloride and fluoride. And the loss of ability here, hydrogen halide ability here, it is that. So this is the order. Okay, and that is hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. So this is the order of loss of hydrogen halide, and whereas this is the order of loss of your halide. So these are the two modes of fragmentation which will happen with the your that is halides. And first one is loss of halide as radical ion. Second one is loss of hydrogen halide, okay, as neutral molecule. And so then here you have, that is, if you sometimes it may happen. Okay, this is another one. Okay, let's have the loss of here the substituted chain. Okay, that is at the alpha cleavage. Here it occurs alpha cleavage. So whether it is a side radical site initiated or whatever it may be. Okay. And you have the loss of your alkyl side chain as radical. Then you have this ion, fragment ion, CH2 double bond X. Okay, methylene halide, and this is the less probably will be occurring sometimes. So then long chain halides, there will be an expulsion if you have a long chain or halides. Okay, maybe here carbon atoms are 4 or 5. Okay. Generally you have the 4 or 5, 6 or 7 if you have, then the gamma carbon will be expelled as radical. So you can see, and then you will have the here the ion, fragment ion associated with the halogen. Maybe it forms a cyclic or something like that. Radical will be expelled here. And coming to this is the state chain alkanes, or okay, which are generally happens of modes of fragmentation. Then next one you have aromatic halides. Then aromatic halides, you know that sorry, generally you will observe M plus peak. because we know that it is a highly aromatic compounds, highly resonance stabilized aromatic compounds, and typically you will find generally you will find loss of halogen atom to give the aromatic cation, the benzelium ion. Phenyl cation you can find out with the, that is M plus P, because of loss of halogen. And sometimes, okay, so here if you see that, if you have, already I told you what is that it is. If we have already, we discussed this long chain halides, what happens with the long chain halides. So long chain halides, there will be gamma carbon atom expulsion, and then you will have generally, that is 5-member cyclic structure will be there. That is typically you will find cyclic structure, and prominent you find with this. That is because 5-member structure is generally highly resonance stabilized. That's what here you can find, that is a expulsion of gamma carbon atom. Okay, gamma carbon atom, and you will have the 5-membered stabilized cyclic cation, and this is what happens here. And then next I told you, so cleavage at addition, that is alpha cleavage, and you will find Z value, that is 49. That is cleavage of alpha carbon atom. This is one that is already we discussed. That is here, this alpha cleavage. So once the alpha cleavage happens, where here, okay. So next to the alpha carbon atom, this is alpha carbon atom next to the alpha carbon atom, cleavage occurs here. Okay, have the formation of alkyl group as radical will be eliminated, and then remaining will be of M by Z value. This is less often it occurs, but still it occurs. You can count for this ion also in the mass spectrum of halogenated compounds. And another one is that elimination of here, that is gamma carbon atom, and gamma carbon atom will be eliminated if you have a longer chains, more than 5. Okay, and that's what here. And of all that, you have this is, which is very stable ion, stable, and 5-member will be stable ion. This next elimination of, okay, elimination HCl also occurs. That is 1,3 position. Elimination of HCl, 1,3 position, formation of -31, -36 peak. You also can find out. Okay, that is loss of HCl, as we already discussed. That is this. Okay. So loss of hydrogen halide, that also occurs. That is generally 1,3 position occurs here. So this is one loss of. So that was we were discussing. So loss of elimination probability will be 1,3, and you with the, it is for M-31 peak MSCl, M-36 peak, and it will be the similar way, HBr or HI, okay, HI or HF, the same way it occurs, but it will generally it will be 1,3 position. And halogenated compounds for aromatic, you will have the prominent peak, that is a minus X loss of halogen, that also occurs. And then final, if it is substituted benzene, then you will have the tropylium ion formation. If it is non-substituted benzelium, that is phenyl cation will be the the most prominent peak. Okay, so and then coming to the examples, if you see here, so chloropropane, you have loss of chloride ion, you can see that loss of X. Okay, loss of X, that is a halide ion. Then you have the M by Z value 43, and then you have the loss of, this is, you can see that so here you can see in the mass spectrum of chloropropane the possible fragments we are trying to find out. So the possible fragments you have here, that is a one fragmentation happens, that is loss of X. Okay. So that already we discussed. This is a prominent one, loss of X, and as radical we have already discussed. And then you have the M by Z value, that is at 43, and that represents the alkyl cation fragment. That is one is the other one. Next one is that cleavage at the alpha carbon atom that we have discussed here already, and here it happens, cleavage happens at this alpha carbon atom and cleavage happens here, and alkyl group will be removed as radical. Then you have this M by Z value 49, M by Z value 49, you have that, okay. And M by Z value 51, that is if we have there are basically two mass units are there. That two mass units, one is because of 49 and 51 is because of that chlorine isotopic abundance, that is chlorine 35 and chlorine 37. Then you can see here it is that M plus peak you can observe, M plus peak you can observe. M plus peak is because of the molecular ion of chloropropane. Molecular weight of the chloropropane is 30, that is 78, that is M plus peak. And next one you can see here, one more peak here. You can, if you see my cursor, position of my cursor, and here this one, M plus 2 peak. Okay, so that means two more mass units are added to the molecular weight of one chloropropane. So that is because of, so the chloropropane will have two isotopes of chlorine. So one here M by Z value 78 is because of presence of chlorine, that is 35 isotope, and M plus 2 peak, that is presence of chlorine 37 isotope. Okay, so between these two, the difference is 2 mass units. That's why you can find the M plus 1, M plus peak and M plus 2 peak. Here M plus peak is M by Z value 78 and M plus 2 peak is M by Z value 80. At 80 you can find one peak, and at 78 you can find one peak. That is at 78, that is we call it the M plus peak, and to the M plus peak two more mass units are added, that is M plus 2 peak. And these two, M plus 1, M plus peak and M plus 2 peak, is because of chlorine 35 and chlorine 37. If chlorine and their ratios also you can see, we have seen that the isotopic abundance. So most abundantly available isotope of chlorine is chlorine 35, and next one is that chlorine 37. So chlorine 35, the ratio of abundance is 3:1, 3:1, and that means most abundantly available isotope is chlorine 35. And next one is the ratio of the intensity also you can see here, 1:3 ratios will be there. So more intense of chlorine 35, that is 3, and less intense of chlorine 37, it is 1. So that means if we take 4 molecules, of that 4 molecules, 3 molecules will be of chlorine 35 and 1 molecule will be of chlorine 37. So 3:1 ratio. Okay, that means 75% of, if we take in consider 100%, if you take the 75% of, or you can take in this way also, if you take 100 molecules, of that 100 molecules, 75% will be 75 molecules will be chlorine 37, and 25 molecules will be of chlorine 37. So with this availability isotopic abundance, you have the M plus peak and M plus 2 peak. So coming to the straight chain here, halogens, straight chain halogens, the one of the possibilities, elimination of halogen as radical or elimination of substituent, that is alkyl side chain as radical. So elimination of radical, that is halide, happens, okay. So that is M minus 35 or whatever it may be, M minus X. So this peak, okay, 43 is M minus X. X represents halide. So from this is a one position where halide will be cleaved off and it will be removed as radical, and this one will be your fragment ion, that is M minus M 43, M by Z value 43, most abundant ion peak. Okay, and next probability we have here is that, so alpha cleavage, second probability, that is second one here is that alpha cleavage that also we discussed, and then we have the loss of here radical, that is alkyl radical will be there, loss of, that is alpha cleavage, and then you have this ion, that is M by Z value, ethylene halogen ion, that is M by Z value 49, or M by Z value that is 51 because of isotopes, that is 5 and 37 chlorine. We have, since our example is, so, or otherwise you have the bromine and bromine also, it will be of bromine 71 and 79 and 81 also, that is the difference will be there. So, and next coming to this is another example. Again, you can see here same way. Okay. So M by Z value. So you can see that loss of here. You can find the M by Z value, that is M minus 35. You can find out here. Same way, here also we have loss of halogen, M by Z value 43. Okay. And you can have the M by Z value here also 43. That is loss of M minus, that is halogen. Loss of halogen from here, the cleavage happens here. Cleavage happens, and you have the M minus 35, or that is M minus XP. Then again you have here M by Z value 70 to 80. You can find out the same thing. So 3:1 ratio, and then you have that is how you count it. Okay, so M minus, that is 63. There is one peak, that is loss of methyl group. Okay, alpha methyl group, that is alpha carbon atom. If alpha carbon atom is cleaved off, alpha carbon atom, if it is cleaved off, you have here also we have seen, if alpha carbon atom is cleaved off, you have the M minus 40 M by Z value 49 is there. And here also you can have the cleavage of alpha carbon atom, and that is M minus 15, that is 63. So compare this compound and compare this compound. So coming to the first compound, so you have a molecule, and from that molecule, as a peak appears at 43, that is because of loss of halogen. And again there is another peak appears, okay, that is M by Z value 49, that is because of the alpha carbon. And then you have the molecular ion peak at any, already we discussed, molecular ion peak generally tries to be at the end of your mass spectrum, and here you have the M plus peak and M plus 2 peak. And coming to the next one, here also first thing is that the probable cleavage for this molecule, you can expect the loss of halogen, and when you lose the halogen, and this is the peak he appears here in mass spectrum, which is most abundant peak, and M by Z value. Okay, that is 43, you have the peak. And the next one we have already, that is less oftenly occurs, is that loss of, okay, that is alpha cleavage. This is the alpha carbon. Next to the alpha carbon, the bond will be cleaved off, and if it is removed, and the loss of mass will be 15. So, and M minus, that is 78 minus 15, 63 you have, and this is M, that is M always represent the molecular ion weight, and M minus 35, that is because of loss of chloride ion. So M minus 35, M value always it will be your molecular weight of the molecular ion. So molecular ion minus remaining that is fragments here. So this is M, again M plus 1 peak, M plus peak, and M plus 2 peaks. So, and this is because of 35, and this is because of 37, and from 78 minus 15, 15 means at the alpha cleavage. So that is methyl group will be eliminated. Next, M minus 35, 78 minus 35. So 35 means here you have the loss of chloride. Okay, and sometimes also we discuss that there will be loss of HX also, that is 1,3 position HX also will be there, that is 36. So you can 36 you can see here, okay, or 36 you can see at 43 by set value. And this is coming to the bromide. Okay, we have seen with the chloride what happens with the chloride. And the chloride, as I told you, bromine, their isotopes will be of 2, and one is with the 79, another one is with the 81. And between those two, bromide, this is a propyl bromide, one N-propyl bromide. In N-propyl bromide, if we take 100 molecules of N-propyl bromide, and of that 50 molecules will have bromine 79 and 50 molecules will have bromine 81. So that is the ratio, 1:1 ratio. Almost we can say this is 1:1 ratio. That is 50:50. You cannot call it as a 51 and 49 ratio, but generally appears 1:1 ratio. So propyl bromide, if you see, the molecular ion peak weight is 122. Another one molecular ion peak is 124. So this we call it as M plus peak, and this one we call it as a M plus 2 peak. Okay, and here this is the most abundant ion which is appearing in our mass spectrum, and to that 2 mass units are added. So when 2 mass units are added, then we call it as a M plus 2 peak. If 1 mass unit is added, then we call it as a M plus 1 peak. M plus peak, this is M plus peak. And then if to this 1 mass unit is added, so here like 1 mass unit is added, then we call it as a M plus 1 peak. Then 2 mass units are added, then we call it as M plus 2 peak. If 3 mass units are added, then we call it as a M plus 3 peak. If 4 mass units are added, and we call it as a M plus 4 peak to the M plus peak. So here you can see this is M plus peak. M plus peak always we take the atoms whose isotopes are most abundantly available. Okay, most abundantly available. That isotopes only we will consider. If you take carbon, and you are taking the M plus peak for carbon, so then we consider only carbon 12. Okay, for M plus peak, we don't consider carbon 13 for M plus peak. Same way, when we take the bromine, we consider 79 for the molecular end peak. So you may think that, sir, why we do not consider this as M plus peak? Why we are considering this as M plus peak? And why we are considering this as M plus 2 peak? So, and here if you see the ratio of the availability of 79 and 81 is 51:49. So most abundantly available isotope is 79. So that molecule only we'll consider for M plus peak. That already we have discussed in the general rules of fragmentation. So the M plus peak is the peak, okay, M plus molecular ion, and that in that we will have the most abundantly available isotopes. So here bromine is most abundantly, in these two cases, most abundantly available is 79. That is why we consider this as a M plus peak, and to the 2 mass units are added, then you have the bromine other isotope 81, and this one is M plus 2 peak. And if we go for chlorine also, you can see that, okay, we are considering here 78, okay, M plus value, that is M plus value 78, M by Z value 78, we are considering as a molecular ion, and then next to that we are considering as M plus 2 peak. Okay. So we are not sorry, why M plus the M by Z value 78 is considered as molecular ion, why not other peak? Because M plus 78 is made up of chlorine 35. Okay, and if you take the isotopic abundance of chlorine, so chlorine 35 is 75% and chlorine 37 is 25%. So now since chlorine 35 is most abundantly available isotope, that's why we consider M plus 78 as M plus peak. Then 2 more mass units are added because of M, that is chlorine 37, that we consider as a M plus 2 peak. So this is with the bromine, and bromine also same pattern follows. Same pattern follows what we discussed for chlorine. Uh, Here, if you see that chlorine, whatever it is, you have the break. That is loss of bromine. Loss of bromine with the M by Z value, M minus bromine, and then you have the cleavage of here alpha carbon atom, that also you can expect, and prominent, so you can see prominent molecular ion peaks, and you can differentiate that. Okay, and whether it is a bromine or chlorine, how you differentiate? If these two peaks in chlorine also you have the M plus and M plus 2 peak, and in bromine also you have the M plus and M plus 2 peaks. So in chlorine, M plus and M plus 2 peaks are 3:1 ratio, and whereas in bromine that is 50 is almost 50:50 ratio, and the fragmentation probability is the same. How it happens with the other, that is chloride ion, you have the loss of bromide here, okay, and as radical, this one there will be loss of, and then you have the alkyl cation, and then sometimes you have the loss of here, okay, that is alpha cleavage, that is this is alpha carbon, next to that you have this one, okay, cleavage will be there, and then you have the, so this is how your this is butyl bromide, and you can see that that is and so cleavage, how it happens here, and loss of, there will be loss of bromide, and that is M by Z value, M by Z butyl bromide, M by Z value 57, M by Z value, and that is for this remaining fragment, and this fragment is M by Z 79. Okay, that is M minus molecular ion peak, you can find out here. So the molecular ion peaks, that is one is M plus peak, another one is M plus 2 peak. M plus peak is because of the bromine 79, M plus 2 peak is because of the bromine 81. So these two appears in 1:1 ratio. That is the prominent, you can how you identify it. And then 136 minus 79, 136, this is a molecular ion. From the molecular ion, so bromine is eliminated. If bromine is eliminated, so M plus, that is M minus 79. So then you get the 58, that is for the loss of bromide, okay, bromide here, and you have the most abundant peak, okay, available of that M by Z value 57. And then next one is that alpha cleavage, alpha cleavage, you have that, okay, here alpha cleavage. So that is the prominent peaks you'll observe. Other prominent peaks also you can count for. Okay, if hydrogen bromide is lost, you have that. Okay, HX. Okay, that's what. Next, you have the aromatic halogen. Okay, halogens. Okay, halogens, and aromatic halogens. The is that loss of, we know that, okay, loss of bromine only, and since it is highly stabilized, and here if you see the bromotoluene, and you have the bromotoluene, and you find that here you see that and plus 2p, and both appear in the same ratio, that is almost the same ratios. So, and that is because of 79, and another one is because of 81. Next one is that loss M by Z 91, M by Z value 91. This peak appears because of the loss of bromide. Okay, and then this is since it is a toluene, and it is undergoes the scrambling internal rearrangement, then tropylium ion stable cation will be formed. So this is for toluene, and for aromatic compounds generally bromide will be lost. Okay, so M minus X peak, that is a prominent M minus X peak will be the M minus X peak. So here M plus value is 79, and that is 170 minus 79, 79. So you have the 91 here, 91. So that is characteristics of aromatic halogens. And here another one is that you have the dibromo, and first one you have the, so here if you see that first one, and two are there. Okay, M plus, here you can observe M plus 2, M plus peak, M plus 2 peak, and then M plus 4 peak. M plus 4 peak is because of presence of, that is bromine 81 and 81. Okay, and this is present. This is first peak. If you see that first peak, if you see that is M plus peak, that is presence of bromine 79 and 79, and second peak M plus 2 peak is presence of bromine 79 and 81. The difference between, and then next one is presence of bromine 81 and 81, and this one already we discussed, 1:3:1 ratio bromine will be available. Okay, that is because of if you have 79 and 79, and if you have 79 and 81, and 81 and 81, so this is the availability, isotopic availability. And we can find here M plus peak, M plus 2 peak, M plus 4 peak. Okay, that means if these two are 79, bromine and bromine 79, M plus peak, and of these two, one is 79 and another one is 81, then you have the M plus 2 peak. And if these two are 81 and 81, then you have the M plus 4 peak. Okay, M plus 4 peak. So then first one you have the loss of, anyway we know that bromine, that is and then second one you have the loss of, okay, loss of 2 bromines, then you have the M by Z value 90. 2 bromines are lost, right? So M by Z value 90. So these are the prominent peaks for the dibromo substituted. So with this we stop here, and next topic is the alcohol. Today our topic was halogen. With respect to the halogens, what is the fragmentation, and how the fragmentation happens, what are the prominent peaks will be appearing, and those are the things we so if you go through the things, okay, what we discussed today, and I think I have unmuted you, then if you go through the topic what we discussed here, and if you have any doubts with your queries, and you can come into the next class, and you can ask the, or any of the session whenever you are free, any of the session we can have the discussion regarding your doubts which you have not followed. So today we discussed about the compound halogen containing compounds, what are the, how the fragmentation happens, what are the prominent peaks you can find in the mass spectrum of halogen containing compounds. So we go through the topic and come with your queries in the next session, or any of the session you feel you're free to ask me. Okay. And one more thing is that remaining people, they have not come. Why?
I send message in group ID password.
Then why they didn't come?
I don't know.
Okay then. Okay. Next tomorrow,
Okay, sir.
as usual, next class.
That fluoro and iodine, sir, why you did not consider only bromine and chlorine? Why we consider in halogen?
Why? I just gave the example. Okay, this is example only. We can consider. Same thing happens with the iodine and brom also. Yeah, I have given you here examples only, two. So same pattern, right? It is not a different pattern. It will be same pattern. That's why I have given you here. Pattern will be same. Okay.
Okay. Okay.